Der Blick auf die Erdkugel. Die Endeavour sollte wieder zu Hause in Florida in den USA landen. Weil sie aber so schnell um die Erde raste und nur ganz vorsichtig sinken sollte, musste sie schon eine Stunde vor der Landung über dem Indischen Ozean anfangen zu bremsen, also auf der anderen Seite der Erde. Etwa 280 Kilometer über der Erde stellte sie sich dann dazu mit dem Hinterteil zur Flugrichtung und zündete kurz einen kleinen Hilfsantrieb. Dadurch wurde die Raumfähre langsamer und sank. Sie traf dann vom luftleeren Weltraum auf die Lufthülle der Erde, die Atmosphäre. Dabei rieb die Luft sich an ihrer Unterseite so stark, dass die Raumfähre zwar glühend heiß, aber dafür auch abgebremst wurde. Und dann wurden die Astronauten wie jedes Mal ganz schön durchgeschüttelt. Aber alles ging gut und die Astronauten haben endlich wieder festen Boden unter den Füßen.
Zeit sicher auf der Erde gelandet. Nach ihrer Reise zur internationalen Raumstation ISS landete das Space Shuttle auf dem Weltraumbahnhof in Cape Canaveral in Florida. Mehr als 12 Tage waren die 7 Astronauten im All unterwegs. Gratulation und willkommen zu Hause begrüßte die Bodenzentrale die 5 Männer und 2 Frauen, die dann mal ganz tief durchatmeten.
Wegen Hurrikan Dean ist die Besatzung der Weltraumfähre Endeavour einen Tag früher zur Erde zurückgekehrt als ursprünglich geplant. Trotz leichter Schäden am Hitzeschild landete der Space Shuttle am frühen Abend sicher in Cape Canaveral im US-Bundesstaat Florida.
Aufatmen im Kontrollzentrum, als nach dem Eintritt in die Erdatmosphäre der Funkkontakt mit der Endeavour und die ersten Bilder zeigen, alles läuft nach Plan. Bis zuletzt hatte der Riss in 2 Hitzekacheln der Raumfähre für Spannung gesorgt. Die NASA hatte sich gegen eine Reparatur im All entschieden. Dennoch machte die Erinnerung an das Columbia-Unglück viele Amerikaner nervös. Doch dann musste Endeavour-Pilot Charlie Hobaugh beim Landeanflug nur noch auf die angekündigten Seitenwinde achten, bis er die Raumfähre sicher auf dem Weltraumbahnhof Cape Canaveral aufsetzte. Die ersten persönlichen Worte richtete der NASA-Sprecher dann an Astronautin Barbara Morgan, die aus dem All mit Studenten diskutiert hatte. Glückwunsch, willkommen zu Hause. Sie haben dem Thema höhere Bildung eine ganz neue Bedeutung gegeben. Bevor der nächste Space Shuttle starten darf, will die NASA zunächst sicherstellen, dass kein herabfallender Isolierschaum mehr das Hitzeschild einer Raumfähre beschädigen kann.
Quick check of some of the other stories that we are following for you this hour. Space Shuttle Endeavour lands safely at Kennedy Space Center. There had been worries earlier about a 6-centimeter gash in the shuttle's belly, but it did not affect the spacecraft's return. The mission ended a day early due to fears that Hurricane Dean would impact operations at Mission Control in Houston, Texas.
Good afternoon from the Kennedy Space Center in Florida for the post-landing news conference of STS-118, mission of the Space Shuttle Endeavour to continue assembly of the International Space Station. I'm David Mold from NASA Public Affairs. With us today is the Administrator of NASA, Michael Griffin, NASA's Associate Administrator for Space Operations, Bill Gerstenmaier, Launch Director Mike Leinbach,
Afternoon,
and the President of the Canadian Space Agency, Laurier Boisvert. We'll begin with opening statements and then we'll go straight to your questions. And now the Administrator of NASA, Mike Griffin.
Thanks, David. I don't usually have much of an opening statement, but on this occasion I made an exception. I've got a couple charts, or pictures rather, that I'd like to show. If we could have the first one of those. This is a shot of the space station that we just added onto. If you look at the right-hand side of your picture as you see it, that's also the starboard side of the station, and on the far right is an additional piece of truss that we added with this mission. And toward the far left, looking a little bit away from you, is the experimental stowage platform that we also added with this mission. So little bit by little bit, we get the station built. We're somewhere over 60% or around 60% complete. And if you look at the next chart, I personally find it hard to look at these pictures and think anything other than that this is one of the great accomplishments of mankind. It's an awesome accomplishment that we're in the middle of. We're not done with it. Every flight is a hard flight. Every flight is the most important flight. And that will remain so until we're done. We don't look at it in the big picture very often. We look at it flight by flight by flight to make sure that we have our attention to the detail that you need to. But when you step back and look away from it, the way that the crew did when they undocked and pulled away, and on that second picture you could see the shot of the shadow of the orbiter on the station. It's an awesome accomplishment, and I think needs to be regarded as such. And oh, by the way, the tile did very well on re-entry. And with that, I'll hand it over to Bill Gerstenmaier.
Okay, thanks, Mike. Again, I want to congratulate the entire team for just a great mission. The shuttle team was phenomenal. They dealt with a lot of really complicated things. We have all 4 control moment gyros now working on space station, which is a great thing. They got all the transfers accomplished. We got the EVA activities that were important done. The teams just did a phenomenal job. And also the work continues on board space station, even though these 7 crew members are home. Our other 3 crew members are still on board the space station, and they're going to move the pressurized mating adapter next week, and that's in preparation for the next mission where we're going to have to attach the node. I got a couple pictures here of some of the tile for you, because I'm sure you'll ask later. The first picture, please. This is the picture taken from on orbit of what the tile damage looked like, and I think you've seen that before and you've looked at it. I also have a mock-up here that we've manufactured essentially based on the laser scan. We had all the point cloud of all the data, which was unique with the boom sensor that allows us to manufacture this 3D model. So we knew exactly what the damage was on orbit, and the analysts were able to go take a look at that. The next picture, please. The next picture shows a run from the ArcJet where we actually machined this same defect into the tile. I think you've probably seen this in John Shannon's briefings earlier. But this was the tunneling we saw. This was kind of the worst case that we would have expected to see with the tile based on our ArcJet analysis. We also backed it up with computer-generated code and also made sure that we were safe from a reentry standpoint with the computer code. And the next picture, this is the actual picture from the runway today. And you'll see it looks pretty much like the first picture, the damage. There's maybe slightly a little bit more erosion on the kind of the forward edge if you look, but not too dramatic. You can also see some of the red material in there. Some of that's filler bar and SIP material, strain isolation pad material. The fact that it's red shows that it didn't get extremely hot and it didn't char. But again, I caution you with this quick analysis we're doing here, the teams will pop these tiles off. We'll take a look at the underlying material to make sure that there's no damage, there's nothing going on. And this data will be tremendously valuable for us. It will help us to anchor not only our computer code, but it'll help us to anchor our test that you saw earlier. So we are going to learn a lot from this activity and this return, and it's great to have the crew back, and I can't say enough for how well they did on orbit. Thanks.
Okay, well, it was a great day to be in Florida to witness Endeavour landing. If you're here in person, you saw it. It's just a beautiful sight to see an orbiter come home to Florida. Endeavour overall out on the runway looks in outstanding condition. From my vantage point, probably the best orbiter since return to flight. Very, very few dings on the tiles. It just looked like almost a pristine vehicle on the runway out there today. So I'd like to congratulate all the folks here at the Kennedy Space Center and around the country that have worked on Endeavour for 4.5 years to get her in flight status. She performed very, very well on orbit. I'd like to congratulate Steve Stitch and all the flight controllers in Houston for executing a phenomenal mission. I'd like to congratulate our friends from the Canadian Space Agency. They'll talk to you here in a bit with Dave Williams on board and their robotic operations. So just a great day for NASA. It's just beautiful to see an orbiter land here. And so I hope all of the Team 105 is out celebrating right now. Congratulations, guys.
Thank you. I would like to welcome the crew back and congratulate them all on a very successful mission. For those watching back home in Canada, I've met Dave. Dave Williams is in great shape, great spirits, and looking forward to welcoming back at the agency in Montreal in the next few days. And as I sit here with you all here today, I'm extremely proud of Canada's contribution to this flight. as you've heard in the media, certainly in Canadian media, Dave broke an all-time record, Canadian astronaut, spending nearly 18 hours in his 3 spacewalks, which we are all extremely proud of his accomplishments during those 3 walks. Also, I'd like to mention the Canadian Robotics, instrumental in the ongoing construction of the International Space Station, as well as the examination of the tile that is probably the most photographed tile in the world. I know in Canada we saw lots of pictures of it, rightfully so. And finally, another comment with regards to the laser camera. The detail that we all saw of the tile was taken by a camera that was developed in Canada. It's a laser camera, and clearly very instrumental in making the right decision that NASA made in not repairing the tile. Thank you.
Thank you. And before we go to your questions, we've got a quick piece of video of the landing to show you.
The landing gear is down and locked. Main gear touchdown. Nose gear touchdown. Deploying of the drag chute delayed to assess the conditions of the crosswinds on the orbiter as it rolls out on the runway 15 at the Kennedy Space Center, wrapping up a nearly 5.3 million mile mission. Endeavour returning the first educator mission specialist Barbara Morgan to Earth to begin the next step in her journey to inspire future generations to explore, learn, and build a better future.
And we'd like to thank our NASA television team for putting that clip together for us. And now we'll go to your questions. Please wait for the microphone to come around and give your affiliation before you ask your question, please. And let's start here in the middle.
Thank you. I'm James Zambrowski with WFTS in Tampa. If ice continues to be a problem with some foam displacement, why don't you de-ice the vehicle in the same manner that some commercial airlines are prior to takeoff?
I guess our... Go ahead, Mike.
Please, go ahead.
Right? I guess the reason really is that our temperatures are so much colder than an aircraft would be. You know, aircraft, you're minus 10 degrees, we're minus 329 and minus 400 degrees Fahrenheit. We're actually freezing some of the atmosphere. We're actually condensing, in the case, oxygen out, and then eventually the ice will form. So there's really not a way to do that. We are looking at a compound kind of surfactant that may make the water beat up a little bit more and may make ice less likely to form, or if the ice forms, it may not stick in those areas. But the primary purpose of the foam is to prevent the ice, which it does a very good job. But that's the problem we have, is we have to make sure we have enough foam to prevent ice, but then we can't have too much foam because then potentially the foam can be lost. So we're walking between those two. But I think the basic difference is why we can't de-ice is just because of the extreme temperature differences between what we have on our tank and what you would see in an aircraft.
Next. Randy Siegel, WSTU Radio. Normally when we have a meeting like this, after a successful landing, everything is really pointing to the next flight. However, in this case, are we pointing to the next flight coming up on October 23rd? Are we looking for it further down the line? And how far back? Also, as a follow-up, that extra hour that you added in to the ICE team, will that affect it if you take it away?
Okay, well, I'll answer the first piece, and then maybe Mike can talk about the ICE team piece. We're still pointed for October 23rd for our launch. We have a meeting today going on to look at the tank to see if there's anything we want to do in terms of modifying the tank. You know, we took extra data on the struts, as you heard yesterday from Wayne. We've analyzed that. We don't see anything off nominal. The teams are meeting today, and we're going to rerun some analysis to see if there's anything we need to do, or we leave it the way it is and head for October 23rd. But I think we're still clearly focused on the next mission. We're ready to move forward. The fact that the space station team is moving to PMA 3 and getting ready for the Node 2 arrival points in that direction. We are 100% focused on where we're heading, and we're moving in that direction. In terms of the hour extra long, Mike can talk about that a little bit, but the idea is that if we don't let the tank stay cold for so long, the condensation potentially would have less ice, especially on the upper parts of these brackets where the water tends to run down and then potentially freezes. So one of the thinkings is that that could improve our situation if we didn't do that. But again, we don't guess and we don't think. We're going to go analyze, and that's what we're doing over these next couple days. When we get through the analysis and the test, we'll probably even do an environmental run, then we'll make the right decision about how we move forward. And Mike, you can talk about it.
Yeah, sure. And if that analysis comes back and says that reducing the time from the beginning of cryogenic loading to launch really does help with the ice buildup, we have a couple of different ways of reducing that time. The most obvious one is that additional hour we put in after ET load for return to flight for all the inspections we're doing. And by the way, that extra hours has turned out to be a very, very good thing for us. But we could reduce that if we need to by a certain amount of time. We also try to start our cryo load about 30 minutes early in order to pick up any issues that we might have with cryogenic loading early in the sequence so we can resolve them quicker. We did that this time. We tanked 30 minutes early. And years ago, when we started our rendezvous missions with the Mir space station and other rendezvous missions, we added 30 minutes to the hold at T-minus 9 minutes. You'll recall, if you remember the early days of the Shuttle program, we had a 10-minute hold at T-minus 9 minutes as well. And so we extended that hold for roughly the same reason, to give us more time to resolve problems late in the count. And so there are a couple different ways we can slice and dice this if it proves out that reducing that time from the beginning of loading to T0 really helps us. So we're waiting on that analysis. If it comes back positive, then we'll look at how we're going to go implement
it. Okay, Jay.
Jay Barbary with NBC for Bill and for Mike Leinbach. I'm told that you've delayed the stacking until you get a resolution to the problem, and that you'll be meeting in, what have we got, a chicken loose in here? Anyway, you'll be meeting in Huntsville on Friday to look at possible any fix, and besides reducing the time the ice has to form, that you're thinking about taking the bracket off, respraying it, and putting it back on. If you have to do any such thing like this, well, can you still make October the 23rd?
I think from the local processing perspective, really and truly it depends on how long we need to do the analysis if a repair turns out to be necessary or not. We were going to make the external tank yesterday for the next mission. That's a true statement. So we're in kind of a holding pattern here. But we've got several days to work with, so we're in no immediate danger of delaying the next mission at all. That's certainly not in the cards. We have some time in the schedule to make up as we go along. So it's going to depend on the result of the study, whether we need to do a fix or not, how long it would take to do that fix, and then what that would translate into for a stacking date.
Yeah, and the teams are pulling together some of the data actually now, and they're reviewing it in some informal technical interchange meetings, and we should have that data reviewed today and probably be ready to at least figure out kind of which direction we want to head tomorrow. So we'll be able to give some more direction based on what we understand today from our analysis and kind of move in the next step in the right direction.
Bill, I'm told that one of your problems is whatever you come up with is certification, that you're going to have to certify it, and that's going to take time. And you might have to come up with a way to certify it.
And I think that's exactly right. I think, again, we need to go look at this. You know, if you remember way back when we talked about ice frost ramps, right, one of our ideas was that this is a very difficult environment to analyze. You can't do this with a single set of computer codes. You can't do it in a single wind tunnel. You almost have to go fly this thing. So then you go fly it, and our cameras and all our systems worked exactly the way we intended them to work. I mean, we know exactly when this came off, where it came off, we know the trajectory it took, and now we'll compare that to our analysis and say, hey, is that the right analysis? Is there something there we ought to change? We'll look at this damage we saw today on the runway and say, hey, is this like what we expected? Is this outside of our bounds? Is this in our experience base, or are we starting to push outside where we need to go make a change? So those are the kind of things that will go into our discussion, and we'll learn from this, and then we'll make the right change. But you're exactly right. When we make a change, we need to be very careful, because we think we make things better, but sometimes we don't when we make a change. You know, if we would have made the original ice frost ramp change, we probably would have increased our potential to lose foam aerodynamically, and in reality we didn't need to make that change, but we only learned that by flying. So there's a reason to fly, and it's truly an experimental vehicle. There's a reason to learn and keep looking and understand, and we'll take the time to go do it. We've got time this week. We'll make a decision at the right time and move forward and see how it goes.
Okay, Irene.
Irene Klotz with Reuters. I have two questions. The first is for either Bill Gerstenmaier or Mike Leinbach. Is the availability of a shuttle and, of course, a tank for CSCS for 120 going to be a factor in making that late October launch date at this point?
No, the availability of the tank is in good shape for the next external tank. Of course, some of it depends on what's decided to do with the tank we have here for that mission, if we have to do any modifications to the next tank in line. And so they all kind of play together. But right now, the tank delivery fits fine with the December launch.
In terms of space station, we're getting more and more robust in terms of the amount of time that we can house the additional crew members. You know, we have the oxygen generation system, which is now available. If you heard earlier, we transferred 1,000 pounds of water. We filled up the oxygen tanks. We filled up the nitrogen tanks. We transferred 12 cans of lithium hydroxide over to station. So we are in a very, very good shape from a space station standpoint to support CSCS.
Question is for you, Bill, or for Dr. Griffin. We all saw the intensity and the focus that you had in analyzing this tile gouge over 6 days, and I'm wondering if there are any concerns anywhere in the organization that the glove issue needs to be similarly kind of ironed out. You've had 2 incidents in recent spacewalks with so far unexplained wear and tear on the gloves. And also, Bill, if you could just talk a little bit about what the supply of gloves is on the space station for the increment walks.
Again, we'll go take a look at the glove. The key piece of data will be we'll be able to take a look at the glove under a microscope and look at the fibers of the Vectran coating, and we'll be able to determine if it was a cut or it was from wear. And then we'll see what that means to us once we understand that piece of data. The last one, if you remember, looked like it was a cut. We have more data. We know what kind of activities were occurring when this happened, so we know those areas to watch. We're also doing an awful lot of translation along the truss. If you've seen during these flights, if you look at the EVA crews, they really translate almost from one end of the truss to the other end of the truss, back up to Z1. They did a lot of activity, so that may factor into the glove wear, and we'll analyze that as well. But again, I think we'll be very rigorous on the glove problem and understand where we are. I think on board Space Station we have prime and backup gloves for all the crew members, and then we also have the Russian Orlan suits available for EVA as well. So we have plenty of EVA capability on board station.
Okay, one more in the front here.
Curtis Kruger with St. Petersburg Times. Do you think that it's as long as space shuttles are flying, there will be some falling foam, some possibility of damage, so that we'll see a repeat of this process, that you have to inspect and analyze and then decide how serious is this?
Yeah, I think that will be the case. I think we will continue to lose foam. Again, we prioritized the areas that we wanted to fix in a certain order, and we're working through those slowly. This next tank, ET-120, has some modifications done to the ice frost ramps that will be like the ice frost ramp modification that we will use on ET-128 or 129 for the HST flight. So we'll get a chance to see that. So I think we're going to continue to keep learning, continue to keep improving. And I think we'll still expect to see some things come off, and we'll have to analyze. The other thing that's amazing to me is, again, the team effort. We flew the RCC this time, and I believe there were about 1,300 regions of interest on the RCC because it was new reinforced carbon-carbon on the wing leading edges. The teams processed through all that in about a 24-hour period, and so they've really got down the methodology that allows them to systematically go through this and make sure we're really ready to go fly. Also they were able to, again, to do the focused inspection. This was the first time we did a focused inspection. We used the Canadian equipment, as was discussed earlier, to get this laser image that allows us to build essentially a plastic tile, but also allows us to machine this exact defect in other real tile and then go take them into the arc jet. So all those things, all those tools that we put in place for return to flight, we got to exercise all those, and I anticipate we will continue to exercise those until the last shuttle flight flies.
Chris Sherman with the Orlando Sentinel for Dr. Griffin. I just wanted to clarify your statement there when you said, oh, by the way, the tile did fine. Was that to suggest that you were never concerned about this particular damage? And to follow up, just can you talk about what the inspection process and all the engineering tests have turned out to be correct, what that does for your confidence in terms of the changes instituted since return to flight?
Well, I don't know that the comment needs clarifying, but I will explain it a little further if that's appropriate. My point certainly would not be that we were never worried about the tile. Obviously, it got a lot of attention during the mission. I personally stayed on top of that, and so did Bill Gerstenmaier. So we were paying an extraordinary amount of attention to it, and of course, with any technical activity, you never know what you don't know until you find out that you didn't know it, and that could be a bad day. So one is never confident. I am never confident that we have figured things out properly until we see it land and see the wheels stop. And I would never want you to infer otherwise. The point I was trying to make with my little remark was that we're building a space station here. One flight at a time, and while I appreciated the media's attention on the ding in the tile, actually the orbiter overall was really pretty clean, and we had one kind of ugly ding, and we paid appropriate attention to it. I would have liked to have seen some media attention on what a magnificent accomplishment we're undertaking here, and I think we're doing pretty well with it.
Bill.
Hi, Bill Harwood with CBS for any of you. Could you give us any update on Barbara Morgan? We didn't see her today on the runway, and I just thought maybe you guys probably have heard a few things.
Well, I don't have an update since I left the runway, but this was Barbara's first flight, and she was feeling just a little bit under the weather, and the flight crew office said she was doing just fine, but she wasn't able to stand up and walk around out in the Florida heat quite right yet. Having stood up and walked around out there in the Florida heat, I was about ready to join her. So nothing more than that, Bill.
Tarek.
Comment Space News. I have two questions, and the first would be for Bill. Bill, based on what you've seen today with the tile, I was curious about how valuable it is to have that practical data to factor in, and what the the step forward would be in terms of folding that in with your analysis and then the engineering that goes on to pry it off and then have a short follow-up.
It's tremendously important. Again, the neat thing is that we have a real understanding of what we started entry with for the first time. You know, we had this computer essentially generated model of what the actual defect is, and that's a huge plus to us. We can now take that and then pop the tile off, look underneath, see if we see any degradation to the strain isolation pad, see what we see to the filler bar, compare that back to our analysis and our code. This will really help us in terms of both improving our models. It'll also help us potentially with heat shield design, even for new vehicles, for the Orion spacecraft. We're going to understand a little bit more how this stuff actually performs. We'll maybe be able to even figure out when we had boundary layer transition, which is important to heat transfer on this particular entry. So again, this is going to be really, really valuable data for us. And what is really important is we have kind of a before and after, which sometimes we've never had before. We see the damage on the runway, but we never knew what it occurred on orbit. And so this new Canadian system that allowed us to get this detailed image is going to be phenomenal in our knowledge as we go forward. And I think we need to not speculate, but let the teams take a look, and it'll be probably a couple weeks, maybe even a month before they get through the real analysis and understand where we are. But then we can talk a little bit more about what we really learned.
Okay, let's go on down the wall to Holly, please.
Mr. Boisvert, can you tell us a little bit about the perception of NASA of space travel in Canada? Is there an excitement about it there that you can tell? I saw that there were a lot of reporters when the crew did their joint press conference last week from Canada asking him questions. Just a little bit about what the perception is there.
Certainly when a Canadian astronaut flies on a shuttle, it gets a lot of media attention, and yes, there is a great deal of excitement. Of all the things that we at the agency participate in, the astronaut program by far gives us the most visibility, the most media coverage, and it is our intent to continue with the astronaut program. Our astronaut corps is getting a little older, like we all are, so we have to make a decision fairly quickly here about undertaking a recruitment campaign. It is my intent as the president of the agency to initiate that process very shortly.
Okay, let's keep going down the wall, please.
Pat Duggins, WMFE and National Public Radio, either for Mike or for Bill. You had the data, you had the pictures, you had the laser imagery, but what were your personal impressions when you saw the ding up close for the first time when you were standing underneath it?
Well, I thought it was darn near pristine, and if you looked down into the hole really closely, you could see what I thought was some stagnation point heating effects, maybe a little bit of erosion on the edge, but overall, you know, a quick look at it, you'd be hard put to tell that it actually went through a reentry.
Mark.
Mark Carreau from the Houston Chronicle. Could you, if you know, could you describe about how much foam you have on these brackets and how much leeway you have in removing some of that foam if it's a potential solution? And I think you've mentioned a couple other things that might be near-term ways to address this issue, and I don't know if there's any more other than this lubricant and changing the inspection time or other parts of the countdown to reduce the exposure.
Again, in terms of mass, I don't know the exact amount of mass on the strut, but it's fairly small. It's on the order of ounces of what we would do. And what we could potentially do is we have a specification on how the minimum thickness of the foam is, and the foam is maybe a little thicker than it needs to be, so we could potentially shave it off a little bit back towards the minimum number, and then therefore we're still within essentially our design capability, but we're trending towards the other edge. Again, I think the teams need to think about all this and factor it in. The thing we sometimes forget is, you remember there's about 4,000 pounds of foam on the tank, and we're talking now about ounces of foam that we're trying to prevent from coming off the tank. So we've really taken this huge complex problem with a large problem to us, and we've really shrunk it down to just very, very few areas, essentially ounce-size there's a foam that we need to go work with. But that shows you the attention to detail, and we'll go look at it again. We'll also look at the trajectory. If you remember, this piece of foam came off and hit the attached strut, the diagonal strut, and then bounced into the orbiter. We want to go run some trajectory cases and see if that was just luck or unluckiness, or that's the typical trajectory that piece of foam from that location will take. So we'll do some trajectory analysis as well to understand and try to quantify the risk and see if we can make the right decision. But again, in our business, a lot of our discussions and decisions are really a risk versus risk discussion. There's no perfect answer. There's no easy way. You know, when we talked about repairing this, a repair isn't like taking your car to the car dealer and getting it repaired. This was a big deal to hang on a 100-foot boom underneath the orbiter with this gun we sprayed stuff with once that doesn't behave always the same way when we spray it to go do that repair. So there's a real risk of that repair. The same thing when we remove the foam off the strut or we redesign the strut, we're interjecting another risk. So our job is to go back and look at this and say, what is the least risk to the program? Is it better to leave it alone and not change it and understand where we are, or is it better to go change it? So you'll see that a lot in our decision process. It was very much the same with this ding on the bottom of the orbiter. Was it better to leave it alone and have it in a known, analyzed condition, or to go out, try to repair it, and put it in an unknown condition? So we're doing exactly the same kind of decision logic with this bracket strut. And that's the essence of what we do in our business. A lot of our decisions are that risk versus risk kind of decision.
I want to add on to that. There's a problem with terminology in the way that we talk about these things. We talk about repair, and we talk about a design fix for the LOX tank bracket or whatever. Those are not the right words. The right word is modification. Okay, we could have made a modification to the shuttle's underbelly on orbit. Whether it would have been a repair or not was in fact the question. It's only a repair if it makes it better, and we haven't done this before. We have some interesting experimental results with doing it on orbit and then putting it in the arc jet. And with regard to the LOX tank bracket, as complicated as the airflow is over the orbiter on ascent, whether any given design change makes it an improvement or not is difficult to answer. As Gerst said a few minutes ago, in some cases we're reduced to saying, okay, we can make a change, but we have to actually fly it to find out because we can't mimic it in the wind tunnel and we can't analyze it. If you'll recall, a while back, now a year or more ago, Gerst and I were in the forefront of those who were saying, you know, let's move real slowly on this ice frost ramp thing until we understand more about why it performs as well as it does. Because the analysis was indicating we should be having all kinds of problems with the ice frost ramps, and we were having minor problems on the scale of things. Well, now we finally understand that, and it's a good thing we didn't jump too quickly. And I think that is the sort of approach that will guide us here. Almost everything about this tank is working well. Almost everything about this tank is working very well indeed. And if we want to pick up that last little bit, we should do that. And the teams are intensely focused on it. But they need to move very carefully.
Todd.
Todd Halverson of Florida Today with a couple for Mike Leinbach, if I could. You mentioned that you intended to mate the external tank ET-120 for STS-120 on Monday. I'm wondering at what point you need to begin that process, the mating process, assembling the stack in order to still make a October 23rd launch attempt, and I have a follow.
Yeah, our schedule has about 5 or 6 days built into that schedule that allows us to delay that mating that amount of time. So by the end of this week, we hope to be given word from the programmer whether we're going to do the modification to the support bracket or not. So we've still got time. Again, we've told the program what our guidelines are here, what our timelines are. We've estimated how long it would take to do a modification if it comes down that way, and that's all being factored in. So. We're not in any trouble yet for the October flight and certainly not for the December flight.
And on the December flight, could you discuss the challenges you're facing with your infrastructure and the ability to stack only a single shuttle at a time, and you're facing, I believe, a 7-day window. And how do you feel about your potential to make that window in December?
Yeah, that's a good question, Todd. We are down to one integration cell in the vehicle assembly building where we do the SRB stacking and the ET mate and the orbiter mate, of course. The vehicle assembly building is an old building, as you well know. We've gone through some modifications to one of the high bays for the doors. We're in the process of doing that on high bay 3 now, which renders it unusable for any real operations right now. So we are single string in the VAB for stacking. That is our critical path. So it's not an orbiter issue now for us. It's stacking and external mate and roll out to the pad. Getting to the 6th of December, again, it's going to be dependent on what modifications are going to be required to the tank, if any, and how long they take to do. We have a 7-day launch window beginning on the 6th of December. So we're all kind of stacking up the same. We've got about a week to play with here. After that, we'll have to start looking very, very hard at our schedules to compress our schedules. And if there's one thing you know about the Kennedy Space Center, well, there's always seems to be a little bit of wiggle room in our schedules. And so I feel pretty good about making it. Again, it's going to be dependent on the modification to the tank if we end up doing that.
Phil Long, the Miami Herald. Just in layman's terms, is what you're saying is you didn't find anything that's even close to being bad enough to cause a problem with the tile that burned through, or any kind of problem that would have endangered the crew of the ship?
Right. It was, our models were very conservative, our analysis and our tests were very conservative, and even those very conservative analyses and tests said that we did not have a safety of flight problem, and I want to emphasize that. When we committed to reentry, it was with the best information we had that said we did not have a safety of flight problem, we might have a maintenance problem. What we saw on the runway today says that even that is quite minimal, as best we can tell right now.
I'm Jeff Patterson with WFLA TV out of Tampa. For Dr. Griffin, 2 questions really. Based on what you said about the potential modification tests to the underbelly for this one tile that we're paying a lot of attention to, did the ArcJet tests indicate that a modification could make the problem worse, or was it just that it wasn't needed? And secondly, with all of the modifications and potential modifications for the experimental vehicle, as you have termed it, how critical is the timeline for launches to the completion of the space station?
Well, I mean, let me answer the second one first. The completion of the space station requires getting our known flights on the manifest in by the end of 2010. We're going to do that, we believe. We, as I've said a number of times, if we continue to fly at our average flight rate, we'll be fine. If something ugly happens, then, you know, it will delay us, but our flights are arranged so that the last flights are the least critical flights. So it's not a matter of having to have that last flight in order to have a viable functioning space station for the advancement of human spaceflight. As I've termed it often, a toehold on the frontier. Now, to your first question, well, the ArcJet testing certainly would lead one to believe that if one modified that tile in an inappropriate way, that you could get recirculating flow down inside the hole of the tile, and more of the tunneling that Gerst showed earlier on, that was about the worst that we thought we would see. And since the tile as is and the worst that we thought we could see was acceptable, doing anything different opens up the possibility that you could make it worse instead of better. And if we thought we could handle the worst case possibility as it was, then you just don't want to even go there when you talk about making a change that would make the worst even worse. You just don't want to do that. And so we elected in the end not to, and it was the right call. Now, that call was not made quickly. It was not made without several tests and many days and, frankly, probably thousands of engineer hours analyzing the situation. But in the end, I think the guys made a great decision, and they did it in the right way.
Okay, I'm told we might have a question from the Dryden Space Flight Center before we come back. Is the Dryden question still there?
Yes, this is Tim Sheehan with the Fresno Bee newspaper. I have a couple of questions for anybody out there. With Barbara Morgan's presence on this flight, obviously there were thoughts of reminiscences of the Challenger accident, for which she was a backup, and then the divot obviously brought memories of Columbia. Given those comparisons, how big was the sigh of relief when this flight came down safely?
I mean, this is Mike Griffin. I can only speak for me. I got to tell you, I breathe a sigh of relief every time we have a successful launch and a successful landing. I've been saying since I took this job that anyone who doesn't understand that in the truest sense of the word, this is an experimental vehicle is just not getting it. This is an experimental vehicle, and on every flight we seem to have some interesting question that has to be resolved. Certainly it's a rare flight where we don't, and I expect that to continue. It's hard to know what else to say. This is an experimental vehicle. I would like very much for everyone to understand that.
And a follow-up from Dryden?
Yes, my follow-up question is, Barbara Morgan was the first of the 4 educator astronauts to fly. When can we expect to have the next educator astronaut fly, whether it's on the Shuttle or the Orion?
Barb is not an educator astronaut. She was selected as a mission specialist some years before, 7 or 8 years before the educator astronaut program was established. The first of those 4 folks has yet to fly, and off the top of my head, I don't know if any of them is currently assigned to a mission or when that would happen. Do you happen to know, Gerst?
I don't know.
Okay. But I would emphasize again, Barb is a regular mission specialist who once upon a time was a teacher. That's not a denigration. My mom was a teacher. But she is not an educator astronaut.
Okay, back to headquarters for Irene.
Thanks. Irene Klotz with Reuters. Dr. Griffin, in the post-launch press conference, you had answered a question a reporter asked about the gap, the 5 years after the shuttle's retired, and you had said that one of your concerns is that the world space transportation system would be down to 1 vehicle. And I was wondering if it was just an oversight that you didn't include China, or is that something that you intended?
Well, for the, I was making, my reference was in connection with the space station program and the partnership there. With the space station, and I showed you the earlier picture of the state of its completion, it's getting to look like a real space station now. That partnership with the United States in its lead, has committed to a, if not permanent, a very long-term presence, human presence on orbit in a much bigger way than the earlier Skylab, Salyut, and Mir space stations, a much bigger way. That station needs logistical support, it needs sustenance, it needs crew rotation. Our Russian partners, after the retirement of the shuttle, will have the only human transportation system, and we will have to scramble with our European and Japanese partners, or possibly with our COTS providers, to provide cargo and maybe crew with our COTS providers. So these things are now in the category of the less well-known. The station was really designed around the shuttle. The station was designed to have the shuttle fly and support it. For both crew rotation and then sort of, oh, by the way, you can have as much cargo as you like. Now we have to have different plans, and again, we're down to 1 single system among the partnership for transporting crew. China is not a space station partner, will not be a space station partner, has not demonstrated the capability for rendezvous and docking and proximity operations that we would have to have in order to even consider having them approach the station. So they're just not a factor.
Todd.
Todd Halverson of Florida Today for Dr. Griffin. Some people looking in might sense that the push you guys have going on right now to figure out what you're going to do with these LOX brackets, LOX feed line brackets, might be being done in a rush. And I'm wondering if you think or feel that schedule pressure, the pressure to finish building the station by September 30th, 2010, is adversely affecting engineering decisions.
Absolutely not, Todd. In fact, the presumption from my perspective, and I know Gerst's because we were chatting about this on the runway just an hour or so ago, the presumption, in fact, is against change. We will have to be, the two of us will have to be satisfied and fully satisfied that a change is necessary and in fact beneficial. So there's no schedule pressure on the folks who think we need to change the LOX feed line bracket to hurry up and do it. They need to hurry up and think about it.
And again, I think if you look at the overall schedule, we really need to take these flights one flight at a time and work the issues to resolution and then understand where we are and then make a commitment to go fly. I think we get in trouble if we start holding up some kind of standard that we have to complete all 14 remaining flights, and if it's failure if we don't get all 14. Each flight pushes the boundary of what we're learning. We're learning lots of stuff for exploration. We're learning lots of stuff that will apply to Moon and Mars. We're going to bring up the international partner flights. We're going to learn how to operate as an international community to do the kind of activity that's going to be required for the Moon. And that is extremely valuable information. So if I end up with 13 flights instead of 14, if I've learned how to operate, I've learned how to be a leader in space, we've learned how to work forward to go to the Moon and Mars, we've gained everything out of this space station. So I think we need to be careful that we don't get so focused on the numbers of flights that is our criteria of success or failure. We need to look beyond the flight number, but look at what we're accomplishing on each flight and see how it fits into the future.
Tarek.
Thank you. This is Tarek Malik with Space.com and Space News again, for either Dr. Griffin or for Bill. This flight was pretty busy for the crew, and it had a lot of changes for them on the fly. They came home early. They had, focus inspection. I was just curious if you could, comment on their performance and kind of adapting in that flight plan and still maintaining their mission goals.
I would just say phenomenal. They did a tremendous job. Just as you described, they dealt with a lot of changes and uncertainty, and they just rolled with the punches, and they did a great job. Having to close the hatch that close after the EVA was a big deal for them to make sure that they had the right equipment, the right spacesuits on the right side of the hatch. That took tremendous focus and dedication on their part to make sure that they did that exactly right, and they did a flawless job with that. So again, I can't say enough about this crew. They're all special, but this one will have many special things along the lines that you just talked about, how they were adaptable and ready to really perform the way they needed to perform.
Well, I'll add on top of that. I don't know, what would you have them do better? I guess that's a rhetorical question, but I can't think of anything that wasn't done just exactly right. What more would you ask for?
Okay. Yes.
John Bracken, WRDJ here in Merritt Island. Could you speak, not about the tile, just about the overall condition of the shuttle Endeavour? There were remarks earlier that it was in excellent condition. Could you make any more comments about that?
Anybody?
Well, again, from my perspective, the external look of the ship was outstanding. One of the cleanest ones since return to flight, if not the cleanest. The problems that were encountered on orbit, I believe I heard a statistic that there was the lowest ever issues on orbit. So it's really a tribute to the 105 team that worked so long to get Endeavour back in the fleet. She performed magnificently. I can't put any better words on. Just a tremendous ship. We got her home now, doing a turnaround for fly again, in great shape in February as well.
Further questions? All right, then, thank you very much for joining us today. For further information, stay tuned to NASA TV or check the website, www.nasa.gov. Thanks, and have a great afternoon.
My apology for that thing. I usually keep it always.
Good to see you.
So open and then introduce you and introduce the rest of your crew.
Sure.
Okay.
Mike's hot. Did you do that, George? Mike's hot.
Good evening, everyone. This is the STS-118 Astronaut post-landing press conference. The crew is back after their 13-day journey of more than 5.2 million miles, and we're glad to have the crew here to talk about it and answer your questions. And we'll begin with our Commander, Scott Kelly. Scott?
Well, it's great to be here today. It's great to be back on Earth after a very successful mission. Let me please introduce my crew first. Pilot Charlie Hobaugh. To his left, Tracy Caldwell. Then Rick Mastracchio, Dave Williams from the Canadian Space Agency, Barbara Morgan, and Al Drew. We had a very successful flight, and it wasn't just due to the 7 of us here. The space station crew was really integral to us completing all of our objectives, which changed somewhat, but due to their flexibility and the flexibility of the folks and professionalism of the folks on the ground, we were able to accomplish all our mission objectives. It was a great experience, and the space station is really a wonderful place, and it continues to get bigger and have more capability to do science. And it's really, I think, a stepping stone to going back to the moon and to Mars someday. And it's really a really great facility for our country and all of our international partners involved. Thank you.
All right, thanks, Scott. And we'll take questions. Please give your name and affiliation when the microphone comes to you, and we'll start right over here against the wall.
Fox News Radio. This question's for Tracy Caldwell. I know you have been working towards this goal for so long, and I know there are a lot of people who are hugely proud of you, all of you. But something you said in an interview really struck me, that to get your PhD in chemistry wasn't necessarily easy, and to become an astronaut wasn't necessarily easy, that you really worked at it, that it wasn't, you know, obviously you were good at it, but it wasn't necessarily something that was the easiest thing. And I've talked to some young girls who say, you know, it's easier to study something else or maybe not study at all, and I think maybe the arc that you've traveled here could be pretty inspiring to them. So, and also you didn't get to sign in space, so I don't want to put you on the spot, but what could you say to people who have a daunting task in front of them, you know, now that you've done this and I know you're exhausted? Thanks.
Well, I think when there's something that you really want to do, you put all of your energy into it, and I have to say that I mean, unless it's something that you really want to do, you're not going to put in the time and the effort. You're not going to be able to overcome those roadblocks that inevitably stand in your way. When it's something that you truly want deep down inside and you've been wanting it for a long time, then you find a way to go over those roadblocks and the challenges. And like I said before, I never saw myself as a chemist, but what a chemist understood was very interesting to me, and I never knew how I was going to learn that stuff, but I wanted to, and that's the key, is wanting to do something, and that's the first ingredient. The rest of it is just a lot of sweat and hard work, at least for someone like me.
Okay, Marcia?
Marcia Dunn, Associated Press for Scott. You finally got to see the famous gouge. What did you think? What were your impressions? And was it disheartening for you to have foam come off and damage your ship?
I was a little bit underwhelmed by the size of the gouge. I mean, we knew how big it was, conceptually we were told on the dimensions, but to see it looked, rather small. And no, it wasn't disappointing. The tank is very complicated. As we continue to fly post-Columbia, every flight we learn things, and we make corrections based on what we learn. So it's part of the process of flying the space shuttle.
Mark?
Thank you. Mark Carreau from the Houston Chronicle, and my question is for Barbara Morgan. How was your flight, and how did you do?
The flight was absolutely wonderful. I'm really proud of our whole team and the team on the ground. It was interesting because we had changes along the way, and that's something we train for, and it all worked out really, really well, I thought. How did I do? It took me a little while at first to get used to the microgravity. Took a couple days, and the first day, I think this was the biggest surprise to me of all, was feeling that you're up. At least I felt like I was upside down that entire first day, and it didn't feel. It wasn't a bad feeling. It was just an unusual feeling when you wanted to turn yourself right side up and you couldn't.
Okay, further questions? Right next to Mark.
Curtis Kruger, St. Petersburg Times, and for Barbara Morgan again, could I ask, how do you feel now? I understand you were a little woozy after landing.
Well, actually, I was doing some good science back there. The room still spins a little bit, but that's okay.
All right, more questions here. The Sentinel.
Hi, Chris Sherman with the Orlando Sentinel. Also for Barbara, could you just talk about your plans going forward? I know you just got back on the ground, but as far as your educational plans, if you'd ever return to full-time teaching or...
Well, my first plan is to get rid of the room spinning, and that should happen pretty soon. What I really want to do is take what this experience was and figure out how we can do a better job or to help serve our students and our teachers in a way that they want, that will be most helpful to them. And I would love to figure out how we can make more and more of these opportunities available for more of our teachers.
Okay, we're going to come over to this side of the room to Irene.
Irene Klotz with Reuters. Barbara, sorry to make you turn your head. You look like you're holding it very still. Would you rather, was it easier adapting to weightlessness, or what you're feeling now is my first question for you, and I have another one.
Probably easier adapting to weightlessness than now, but don't get me wrong, this isn't that bad. It's just something, it'll go away, and it's actually pretty interesting if you could be in my body.
The other question, and this is totally not good timing to ask you this, but you told me before the flight that you didn't think that you ever had to work harder as an astronaut as you did as a teacher, and I'm just wondering if you want to take back your words.
No, I don't. Now, they are both very, very challenging jobs, and I would just say that being an astronaut is no harder necessarily than being a teacher, but they're a different kind of challenges for both. But I think people underestimate the work. These guys make it look really easy. They really do, and it is extremely difficult. So I don't want anybody to underestimate that. But I also think the teachers who are working in our classrooms, I think people underestimate how challenging that is too. And when you take when you have the responsibility for the future of those kids that are sitting in your class, and you're designing a learning environment for every individual. And those individuals all come with different challenges, with different backgrounds, with different hopes and dreams, and different personalities and all that, and try to create the best learning environment you can. That's a very challenging job, too.
I'm Sandra Frederick, Daytona Beach News Journal. Welcome back, Scott. This one's for you. When we talked in June, you were excited about learning what it felt like to touch the control and bring the bird home. How was it?
Well, it flew a lot like our simulators we have. It certainly was, interesting and exciting. There is a difference between the simulators. For one, when we're flying the shuttle landing airplane, it's for most of the kind of the approach turn, you're accelerating, and in the case of the orbiter, you're decelerating from very high speed, at least initially. So it's somewhat different. The major factor is how you're feeling and the vestibular effects of being in microgravity, and that certainly is what provides the challenge to landing the shuttle, I think. But all in all, it went well. I think I'm pleased with the landing. I'm more pleased with how my crew and the station crew executed our mission. The landing's only the end of the flight, but we had a whole lot more hard work going on, and they really executed it flawlessly.
Let's come here to the center.
Thank you. This is Tarek Malik with Space.com and Space News, and my question is either for Rick or for maybe for Scorch. You've been to the space station before, and it looks, I would imagine, a bit different than that first time. I'm curious, what were your first impressions, and how do you feel leaving it in a slightly larger state?
Rick would be glad to answer. Yeah, the last time I was at the space station, there was no one living there, and it was quite a bit smaller. So obviously the first impression was it's a lot larger. Second impression is it's a lot more cluttered. There's a lot more equipment up there, a lot more stowage. And obviously there's 3 folks living up there, and they've actually made a home out of it. And it actually, they've done a good job. It actually looks fairly comfortable up there. They got their own little sleeping stations, and they got their own little private space, and it looks pretty good. Other than that, it looks pretty much the same.
Right, let's come over here to Dan.
Dan Billow from WESH-TV. A question for Dave Williams. I've been kind of struck by the enthusiasm of your descriptions of space flight. So could you bring it home? Kind of give me a sense of what it's like. What does it feel like to spacewalk, to see the space station, to land? I mean, what strikes you here?
Well, there's so many different elements to the spaceflight experience. I mean, launch itself, you've got the tremendous power of the shuttle and the 3 main engines, the 2 solid rocket boosters beneath you. It's truly the ride of a lifetime, going from being on launch pad 8.5 minutes later to being in space. Once you're in orbit, to me, the most spectacular part of being in orbit is essentially the view out the window. I mean, it's absolutely breathtaking, but when you get outside and you're doing a spacewalk and you can see a quarter of the planet sort of in front of you, and you see these sunrises and sunsets every 45 minutes, and here we are working away doing spacewalks, and someone will say, look over your shoulder, and you can see Hurricane Dean below you, and you can see this gigantic hurricane really spanning across the whole area that you're looking at. These are moments that you truly take away with you, and I was telling Ellen earlier on that in our 4th EVA I looked up at Clay Anderson as we were working on the Eva antennas and had one of those moments where the moon was right over top of his head. And that was just a spectacular thing to be able to experience. So it's really that human experience of being there and getting a chance to look at the spectacular beauty of the world. The other element of spaceflight, though, is a technical one. It's working together as a team. And we had a great team. It was a great mission. It was just really, for me, a thrill and an honor to be part of it. Landing, different ride, lots of G's coming back.
Any further questions? All right, let's come over here to Patrick.
I'm Patrick Peterson with Florida Today. This question is for anyone
your mission got extended and then it got cut short. So did you lose some of your free time that you might have spent gazing out the window, taking some pictures of Earth?
Scorch? I'll take that one. You know, you kind of pace out your flight and have expectations of what you want to accomplish in a certain day. And that last day on station, there was personally some times where I just wanted to take some pictures out of the SM windows, go back and just kind of relax with Oleg Fyodor and Clay and take advantage of some of the things on the station that you really don't have time to enjoy because you're so busy trying to get everything done. Barbara's doing a great job of getting transfer going, but that was one of those things that you just had to keep nibbling away at. So when you had free time, you just had to keep pounding away at getting bags to and fro across, getting them stowed, getting them in the place they need to be. And so you kind of paced out to say, hey, if we get all this stuff knocked out early, then you can kind of take a day to relax. And then when we got the message that, hey, you know, because of the hurricane, we're going to have to cut you a day short, you just kind of compress that time a little bit. And I think it was a great decision just because that decision's not for us. It's for the people in Houston that are concerned about their homes, their families, what kind of egress plans they're going to have. You know, when we had our first hurricane a couple years ago that we've had in a while, and you have that mass exodus out of Houston, it's really a nightmare. So, you know, to make sure that they're taken care of and we're doing what's best for them really means a lot, I think, to us to just say, hey, you know, it's not about us, it's about everybody, and we want to do what's right for the people that are supporting us. But it was a little bit of a disappointment, but it was actually quite easy to get everything done that we needed to get done. We had a good plan for it. Everybody knew what had to be done and just kind of ran on automatic and pitched in. So it worked out really well, but it is, you know, a day lost in space is something you can never make up for, and it's a great place to be.
Okay, further questions? Let's go back here along the wall again.
Curtis Kruger, St. Pete Times. We had a lot of discussion and coverage of that hole in that tile, and I wonder if any of you or all of you could talk about what went through your mind during re-entry. Was that tile damage on your mind? Did it concern you as you were re-entering?
To be honest with you, it crossed my mind for a moment only in that the sense that I knew I was going to be asked about it, and that I didn't worry about it at all. I mean, when we were informed of the type of analysis and testing that was going on, and the rigor and the time that was put into it to make the right decision based on the data, I was as certain as I could be about anything that it wasn't going to be an issue.
I thought it was kind of interesting out of all that you know, the mission management team and the multitude of people that got involved in trying to resolve this problem was really amazing, and it didn't occur necessarily at a very good time of the week or you know, the day of the week or the times of the day. We were looking at our watch, and the MMT's going to meet late, and it's going later and later in the day, and we're like, man, these guys are really killing themselves to get an answer for us, and it's very humbling to know that that type of people that are working on this problem, to include Mike Griffin, who after the flight said, I want you guys to know I was following this all along, and I hope you knew I was there for you. I'm like, I don't want to bother my boss on high with something like this when he's got people below him that are really working this hard. But yeah, like I said, it's very humbling to have the hierarchy that are deeply entrenched in this kind of issue to take care of it, that they're really working the long hours. I thank them for their time. But the thing I have learned is if a thermal guy comes back to you and says, hey, you know, you're gonna be fine, guaranteed you're gonna be okay. If they say you're not gonna be fine, you might be okay. They're very conservative.
Okay, Marcia.
Associated Press for Barbara. I'm wondering if you wish the flight could have been restructured such that you could have had more teaching time and maybe even offered real lessons from space.
Well, let me answer the first part of that question. It would first. It would always be wonderful to have more time to do more education, but one of the many things I learned that we knew going in, but when you're up there, it really gives you a sense of this. These missions are so incredibly packed with things that have to be accomplished, and education is right up there at the top, but when it comes to constructing and doing everything else that needs to happen for us to be able to go to the moon and go on to Mars, I feel very grateful that we got the time that we got. I really, really do. And I forgot the second part of your question already.
Do you wish you could have done a true lesson from space that could have at least been videotaped when school started everywhere, as opposed to just having a question and answer format?
Well, and I'm really glad, that's why I wanted to answer that second part. What we did, which was ahead of time, we weren't quite able to accomplish it exactly the way we wanted to, but we're learning, and we wanted to set this up as a model for the future. But really what happened was exactly how many of us teach in our classroom, and it's certainly the way I taught. Very rarely, if you were to come into my class, would you see me standing up in front of the kids lecturing, or giving, anything more than maybe 5 to 10 minutes of some information that they would need to go off and do the kinds of things that provided them for active learning, active participation, and then I would be there to help them as they went through their learning process. So I'm really proud of what we did. We set up a great ground-based program. We've got 10 million basal seeds coming back. I cannot wait to see, and I hope we get kids all over the country and beyond designing growth chambers for us for the moon and Mars, and let them take these seeds and do what we get to do. We're not going to test them on it. We're going to give them these seeds and let them experiment, explore, discover, do whatever they want with them, and get to have the kinds of experiences that we have.
All right, we'll take one more question from Irene, and then that's going to wrap it up.
Thanks. Irene Klotz with Reuters. This question's been asked probably hundreds of times in the 50 years or so that there's been space programs. But Barbara, I'd like to ask you if you think that the experience of flying in space and being able to see the Earth from the God's eye view changes you in some way.
Boy, that's a tough one to answer. Can you ask that again in maybe a couple weeks from now? No. There's a great sense of pride to be able to be involved in a human endeavor that is that takes us all a little bit farther, and to know that we are a small part of what's going to get us beyond and back to the moon for the long haul and onto Mars, and to get to experience that, and as Dave so eloquently put, to be able to see our planet. And I'll tell you, the blackness of space, I've never seen anything that black. And at first it was like obsidian, only blacker and shinier and creamier, or smoother, I would say. And when you look down, excuse me, and see our planet Earth, or you look up, depending on whether you're up or down, and you realize what we are trying to do as a human race, it's pretty profound. And you ought to ask my crewmates here, because they can say it much more eloquently than I can.
All right, thank you very much. And that will conclude our briefing and our coverage of STS-118. Thank you.
Thanks. Yeah, thank you. Yeah.
Good morning, and welcome to NASA headquarters here in Washington, D.C. My name is Bob Jacobs. I'm with the NASA's Office of Public Affairs, and thank you for attending this morning's presentation by the most recent Space Shuttle crew to successfully complete another critical flight to the International Space Station. Again, it's great to see all the NASA headquarters employees and their families here today. And I also want to acknowledge the students that are in the audience. As most of you know, there was some emphasis on education during this last flight, and our astronauts took the opportunity during the mission to interact with a number of students here on the ground. So let's get started. It's now my pleasure to introduce the Deputy Administrator of NASA, the Honorable Shannon Dale.
Thank you, Bob, and thanks to all of you for being here, but honestly, why wouldn't you be here? Because we've got the crew of STS-118 with us here today. And I have to say that their mission was incredibly successful. Due to their efforts, the International Space Station is now over 60% complete. It was a hard, complex mission, and they performed everything that they needed to do flawlessly. So we are deeply honored with their presence here today, and also anxiously anticipating their discussion of their mission. As they start the completion of the International Space Station, which will yield incredible research and technology development, we're also moving that much closer to our next toehold in human space exploration, and that's our outpost on the moon. So thank you guys for a job wonderfully done, and at this point I would like to introduce the commander of STS-118, Scott Kelly.
I'd also like to thank everyone for being here today. We really look forward to talking to you and telling the story of our mission. We also look forward to answering your questions afterwards, especially the kids out there. I think one of the common themes of STS-118 was teamwork. We had a very, very complicated mission. We had many kind of curveballs thrown at us during the flight. And because of the great group of people that work at NASA, both obviously here at headquarters, but also around all the NASA centers, we were able to be successful, and that's due to teamwork. And I think this flight really showed how important teamwork is to doing something that's very, very difficult, like building the International Space Station. I'd like to introduce the crew of STS-118, the pilot, Colonel Charlie Hobaugh from the United States Marine Corps. Mission Specialist number 1, Dr. Tracy Caldwell. Mission Specialist 3, Dr. Dave Williams. From the Canadian Space Agency. Mission Specialist number 4, Barbara Morgan. And Mission Specialist number 5, Colonel Al Drew from the United States Air Force. And not with us here today is our Mission Specialist number 2, Rick Mastracchio, who couldn't make it here today because he was selected to be on a jury. So since we're done with our flight, we're no longer important enough to get out of jury duty, I guess. With that, we'd like to sit down and we're going to run a video. We'll show that video, and then we'll have an opportunity to answer all your questions. Thank you. Well, this is our patch. It was designed by our crew, mostly Dave Williams. Here's us in the suit-up room. Same as suit-up room, actually, that was used during the Apollo program. Here's Charlie getting his gloves on. Tracy, miraculously poised for a first-time flyer. The juror on the crew. And Dave Williams relaxing. And there's Barb looking also very poised for her first flight, as well as Al. We actually walk out of the suit room about probably about 3.5 hours prior to launch. We actually don't walk this fast. I think this is sped up a little bit. It's kind of hard to walk in the suits. And here's Endeavour on the launch pad. Endeavour had not flown for for several years, and it was really an incredible vehicle. This is us in the vertical getting into our seats. Crew members in the white room. The white room attaches to the side of the orbiter. This is a view from the middeck. And Rick Mastracchio, he's one of the last guys to get in as Mission Specialist number 2.
During the launch, we spent a lot of our training, I'd say just roughly 60% of our time getting ready for this specific event. The whole thing happens in 8.5 minutes. The orbiter, when you get there, is just a living, breathing thing. Everyone's been cleared away from 3 miles. You know you're about ready to go for the ride of your life. Here's a little inset photo of what it looks like from inside the cockpit. The jostling you get is when the solid rocket boosters ignite. They're about 2.5 minutes for their phase of flight, and when they ignite, there's no doubt in your mind you're going somewhere, and you're going somewhere in a hurry. We have some pretty good sound here. It's just not coming up. The whole ascent phase, 8.5 minutes. You know, you get up there, the main engine's cut off, and within that period of time, you're now trying to figure out, with 60% of your training done, what you're going to do for the next 2 weeks in the mission. Pretty good shot here of the when the solid rocket boosters separate and we separate away from that. It's a pretty smooth ride now on the main engines. You go from about 2 some G's on your chest to about 1. And then as you burn down the fuel, you get to about 3 G's. It gets kind of hard to breathe. You really got to be deliberate in your actions. It's kind of hard to move around. You're kind of pinned to your seat. And then as soon as the engine's cut off, you're just thrown forward in your straps.
And as soon as you do have main engine cut off, both Dave and myself unstrapped from our seats and grabbed cameras and then shot video and still photos of the external tank as it fell back down to the ocean. And those pictures were later analyzed by our teams on the ground. Then on flight day 2, we got busy. We unberthed the orbiter boom system and began inspecting both the wing leading edges and also the nose cap for any damage that may occur on ascent. On the 3rd day, we began our rendezvous phase to dock with the International Space Station, and you can see here the photography of us getting closer and closer as we approach.
Yeah, because of the damage to Columbia, we now do this rendezvous pitch maneuver, which allows actually the autopilot is flying the vehicle, but we go through this 360-degree pitch to take pictures of the bottom of the space shuttle from the International Space Station. The crew members are snapping a lot of photos here, and that's to just document how the bottom of the vehicle looks. Here's a picture of Endeavour as we approach the International Space Station. At this point, I would be manually flying Endeavour and trying to bring the 2 vehicles very bringing together like we see here, although this is again sped up. Didn't really actually dock this fast. Probably would have broke something.
We have capture,
not capture. We have free drift.
With us together, finally, the next thing is to seal the hatches between the 2 vehicles so we've got an airtight seal. And this is us working that right now. Once that's done, it's time to go aboard the space station and begin working. It's kind of like a debut night on any movie in Hollywood where the paparazzi await. I believe at this point there are probably more cameras than there are astronauts aboard the space station out available at this time. And here are us greeting the crew and comparing our photographic equipment.
After we said our hellos, it was time to kind of get ready to do the rest of the day's work, getting ready for the next day's spacewalk, and also Tracy and Scorch here, Charlie Hobauer, were getting ready to hand off S5 to start the next day's activities.
And you see that here in the video. The shuttle arm is grappled to the S5 truss and handing it over to the space station arm for installation on the next day with the EVA crew members outboard. And there you saw a picture of Charlie at the workstation, the robotic workstation, as he maneuvered the truss element to its position.
Although the S5 isn't very big, it's very, very important.
Absolutely.
And one of the really exciting parts of the mission was the coordination between the robotics and the spacewalk. So Rick and I are coming out of the airlock. We're translating, moving hand by hand out to the S5 area where Scorch has brought S5 up. Rick and I watched and monitored as Scorch brought the S5 into the soft capture position. You can see the pins dropping down. And then our first task was to drive the large bolts that hold S5 in place. So we got these foot restraints, we moved them into position, climbed into our foot restraints and drove those bolts. And it was pretty amazing actually watching S5 finally get attached to the station, realizing that we're expanding the station in length.
Of course, meanwhile, inside we had lots of transfer, about 5,000 pounds of cargo to bring aboard the space station and 4,000 pounds to bring back down to Earth, as well as a bunch of repairs on this old station. And there's a Scorch down there replacing one of the scratch panes on the window.
On this day of the flight, this is the day after the first EVA, we did what's called focus inspection. We had to move this boom from the payload bay of the orbiter using the space station's robot arm, then hand it off to the shuttle's robot arm, very complicated robotics task, and that's so we could go underneath the bottom of the space shuttle and take pictures of the spots of concern on the bottom of the vehicle. And here was the main damage area that we had.
On our second spacewalk, we went outside to replace one of the gyroscopes on board the space station. There are 4 gyroscopes that are used to stabilize the position. Rick is now removing the covering of the gyroscope that we replaced, and all of these are up on an area of the station in the center of the station called Z1. So Rick and I came out of the airlock and translated up hand over hand to Z1 to be able to uncover the CMG or the gyroscope and be able to replace it. We use drills, essentially like a power tool on the ground, and we put a socket on there and we undid the various bolts that were restraining it. Rick then grabbed onto the CMG, which weighs about 600 pounds, and he did what we call a layback maneuver, kind of bending backwards at his waist to be able to lift the CMG out of the way, and then he handed it off to me and we restrained it temporarily, putting it on what's called a mutt ball stack mud. It's basically a tool to restrain it to the space station. I climbed onto the end of the robotic arm, and Scorch did an outstanding job driving me over to the payload bay to get the new CMG. This one weighs about 1,200 pounds, and I spent a lot of time in the gym getting ready to be able to lift this thing out of the payload bay. But surprisingly enough, it was a lot easier than I anticipated, and Scorch moved us out of the payload bay. We had about 2 inches clearance from something called the nitrogen tank assembly that was right beside us on the stowage platform. That's a pretty spectacular view. You know, I'm glad somebody recorded this because all I saw was this big CMG that I was holding in my face. I didn't get to see the view. That's kind of what I was seeing, except I saw more of the gyroscope itself. But we brought the old one down to one of the work sites on the stowage platform on the space station. Rick came back from the payload bay. We kind of rendezvoused and put this new one here on the stowage platform, and then we essentially did the swap, taking the new one and replacing it with the old one. But to do that required us riding on the arm back and forth between all the various work sites, and Scorch drove me back up to pick up the old one that had failed, and Rick and I finally installed that and swapped it on the external stowage platform.
Well, there are several different ways of building the space station, and you've seen a couple examples. We put the truss on with robotics and spacewalking, and the gyroscope with robotics and spacewalking. This particular payload that we're taking out of the payload bay right now, with the shuttle arm and handing it off to the station arm, is a big stowage platform that we attached to the International Space Station. And that was all done robotically by handing it off from one arm to the other and then floating over to the International Space Station side and using the computers on board to send commands to latch the this platform to the International Space Station. And this platform holds a bunch of spare equipment for future uses on the International Space Station.
Yeah, and this type of equipment will be really important in the future as we stop flying the space shuttle, to have a spot for external spares.
Next thing we got to do was education, talking with school children, this time to the Challenger Center just across the river in Arlington, Virginia.
And that was our way of honoring the Challenger crew from years ago. Our favorite education thing that we did on orbit, besides having fun here, to show Newton's laws, we took up that pink package that you see there has a whole bunch of basil seeds. We took up 10 million basil seeds, and they're getting ready to be distributed now to schools all over the country, and I hope all you kids in here make sure that your schools get these as well. And we'd like to challenge you to help us help answer one of the many, many questions that we're going to need to figure out when we send people back to the moon for the long haul. And how are we going to feed folks? So we'd like to challenge you to design some growth chambers that can be used on the moon. And who knows if basil's what you'd want to grow? It's all up to you to help us decide.
I was concerned some of those 10 million seeds were going to get away, but fortunately they didn't. So it would have been a mess.
What they did was gave a beautiful aroma inside the space shuttle and space station.
Before every EVA, there's a tremendous amount of work that takes place inside the airlock, just getting the guys ready, or gals, ready to go outside the hatch. And so you see footage here of Scott spent most of the morning getting these guys dressed up and in their suits and pressure checks, and then I would come in later on and help put their tools on them and get them inside, packed inside the crew lock and ready to go out the door. You see it's not a whole lot of room to work, but having no gravity sure helps. Once they're tucked inside the crew lock, then we shut the hatch and then begin to depress the airlock and start getting the guys out.
So on the third spacewalk, Clay Anderson and Rick went outside to do that one. I was actually inside for that spacewalk. Clay did an absolutely outstanding job, and as you all know, he's still in space right now. He just celebrated his 100th day in space. But this was a spacewalk that was essentially focusing on communication equipment, and there's a great shot of Rick on the end of the arm. He had to transfer what's called an S-band antenna, and this is essentially part of the communication system for the space station. And we're moving things around just to allow us to move that large section in the center of the station called P6 out to the port side of the station. So Rick had to move some of the equipment from P6. Clay was also working to install what's called a BSP and transponder, again, two elements of the space station communication system. After they did that, we had to move these CETA carts, and the center of the space station is this long truss, and on that we have the equivalent of a railroad, basically, and these CETA carts allow us to put equipment on and move the equipment from one location to another on the station. But we needed to move these to the starboard side of the space station. There was a great shot of Clay up on the end of the arm, and during this whole process, at some point, Rick got a nick in his glove, and this is a shot of him looking down at his left glove, showing where the nick is. We terminated the EVA a little bit early, came inside, and then Clay and I took some photographs of the glove to be able to send it to the ground for analysis.
Because of the damage we had on the bottom of the vehicle, we were talking about maybe doing 5 spacewalks, perhaps the longest shuttle flight in the history of the shuttle program, to repair the damage. But all the analysis that was done on the ground determined that that wasn't necessary. And then we had Hurricane Dean, as you can see here, brewing in the Gulf, and we had to go from figuring out how to fly maybe the longest flight to now try to do everything we needed to do in much less time. Do our last EVA, as you see here, and then close the hatch early and undock early and come home.
So for the fourth spacewalk, Clay and I had a chance to go outside and do that one. As Scott mentioned, we changed the choreography of the spacewalk literally the night before to shorten the spacewalk to enable us to get back in earlier, to close the hatch, to be able to undock. The large structure that you can see on the side of one of us is a stanchion to hold this boom on the space station. When I came out of the airlock, because of all the things that were in the airlock, the hand controller for my jetpack, if you will, deployed itself. And when we do a spacewalk, we always wear this thing. It's called a safer that enables us to fly back to the space station if we inadvertently came off structure and the hand controller for mine kind of popped out. There's a great shot of us translating up to the work site. After we installed these stanchions, I went and worked on another communication antenna to lock it in place to enable us to move P6, and at the same time Clay was out working to retrieve an experiment that had been put outside in the space station, and he's now getting ready to bring this back inside. You can see him going to stick that on the end of his BRT, which is a tool that you use to grab onto things when you're out in space. After we finished that off, we went to the end of the lab and installed an EVA antenna system that allows us to take these kinds of images from our helmet camera. Tracy said, "Hey guys, look over your shoulder," and we looked down at Hurricane Dean. It was going by underneath us. Absolutely spectacular view. But we wrapped up the spacewalk after about 4 hours or so and got ready to come back inside, closing the thermal cover and the hatch to the space station's airlock, get ready to undock.
And with that, it was time to say our goodbyes. Here we are saying goodbye to Fyodor Yurchikhin, Oleg Kotov, and Clay Anderson.
Undocking is a pretty fun event for me. It's the one flying task I get to actually execute. If anyone would like the landing, that wasn't done by the pilot, it's done by the commander. I guess Bob Crippen and John Young back in the day didn't want to have a guy named a co-pilot, so they call him commander and pilot instead of pilot co-pilot, but I'm really the co-pilot. So Scott flies the docking, I get to fly the undocking, and this is a space station as we're separating away. And then, of course, Scott will do the landing. For our flight, again, it was pretty busy on undocking day. You basically wake up in the morning and get ready to punch off when the lighting is correct. You get everybody in position. You got 7 people cluttered on the flight deck. Everybody wants to take pictures, get a piece of the action, and somebody in there is supposed to actually safely separate from the station. That's supposed to be me. It was really a pleasant event. My first flight, I got to do a full fly around. We actually shot a 3D IMAX video. For this one, we just separated out directly ahead of the station and then did what's called a separation burn, where we just do about a 3 foot per second acceleration to get away from the station. And after we did that, you're pretty much in a safe trajectory. And we really took a long time to take a bunch of great pictures of the station.
A couple days after we undock, it's time to come home. Here's a view of the flight deck of us back in our pressure suits that have been put away for about 2 weeks.
3, 2, 1. Easy left turn on the heck. Light winds all the way around.
And here's a view of from the ground of the shuttle as we fly around the heading alignment cone. And you can hear some of our cockpit audio, so I won't talk a whole lot over it.
Good, good. 3,000. Speed brakes going close. Looks like about 7. Okay. 2,000. Pre-flare. The pre-flare arm the gear. Gears arm got a light. 1,000. 307 max. 9, 8, 7, 6, 5, gear 3, 400 feet. Gears on the way.
Shuttle's a big glider.
Good energy through the threshold. You're on the ball bar. Good job. 5240, 4235, 3230. Let it keep coming. 2225, 10220. Good left correction. Your touch.
We had some crosswinds to contend with during this landing that was, you can see in this video.
All right, good.
It was so smooth, only one of us could actually feel the wheels touch down.
Congratulations, welcome home. You've been given a new meaning to higher education.
After the flight, we had the opportunity to walk around the bottom of the shuttle. We're actually kind of dizzy here, and we're trying not to look like we're dizzy. And here's us looking at the damage. Quite underwhelming, I think, was what I thought about the little ding on the bottom of the vehicle. Well, that's kind of a quick summary of our flight. I'm not sure exactly how much time we have, but we'll be happy to take any of your questions. Yes, sir. What was my main job on this spacecraft? Well, as the commander, yeah. As the commander, you're kind of as the crew member, you're the crew member that's ultimately responsible for the mission objectives and safety, and you're also the guy, like Colonel Hobos said here, that does most of the flying. So you're like the pilot as well.
I think another thing to add to that is that everybody is given a specific job on the flight. There's so much to do that not one person can be responsible for everything. So the responsibilities are very delegated out. So Scott will decide who does what,
And then once you're given that task, you're overall responsible for that thing, and you answer back to him and the flight control team, and you work with the people that are responsible for that specialty, and you make sure it all goes right.
Yes, sir.
How hard is it to land the shuttle?
How hard is it? You know, it's I think if I was just to go in the shuttle right now and land and try to land it, it wouldn't be very hard at all. I think what makes it challenging is the fact that you've been in space for a couple of weeks, and you, by not having gravity affecting you and then coming back into gravity, it makes you dizzy, and I think it affects your vision some. So because of that, it becomes a challenging flying task. The shuttle also has some unique things about it that make it a little more difficult to fly than it should be, but mostly it's due to that being in microgravity and then coming back into gravity that makes it hard. You practice many practice landings in an airplane. For this one shuttle landing, which is likely probably the only one I will ever do, I've landed this shuttle training airplane 1,500 times. So you practice a lot for it.
Oh, how did you guys become astronauts? Like, what was the process?
Tracy?
You have to fill out an application. Oh, you want more than that?
That's really good detail.
Thank you. I was trying to be brief. You know, there's two flavors of astronauts right now. There's pilot astronauts and there's mission specialists. And the pilots are what you see here with Charlie and Scott. They are brought up in the military as aviators, and they have thousands of hours flying high-performance jets, landing on carriers in the middle of the night. So their background is something that they're probably best speaking about how they get to the astronaut program. As mission specialists, they look for, right now, engineers and scientists for the most part, medical doctors, as well as teachers, and folks of all sorts of backgrounds. And for the most part, you fill out an application and you go through a lot of school. And and for me personally, I had been inspired when I was in high school to pursue the astronaut program based on all the interests that I had at the time growing up. And not one single career seemed to stick out in my mind. And at 16 years old, I thought it was very important I had that figured out. And my parents told me that it was more important that I figure out what I wanted to do rather than what I wanted to be. And as such, encouraged me to write a list of all the things that I liked to do at that time. And many of the things I liked to do involved the things I was doing in high school, which were learning science. Though I didn't feel like I was very good at it, I really enjoyed learning about it. And I was part of many different types of teams, both sports teams as well as academic teams. And I also liked working with tools. Oddly enough, I was an electrician at a very young age, and worked with my father in that field as well as working on other mechanical systems. And all these things I knew that I would have a lot of fun doing if that's what I got to do the rest of my life. Though looking at the collection of interests, I couldn't figure out what I wanted to be until the whole world started talking about NASA and the Challenger mission. And this was, of course, before the accident, but when everyone was in awe of Krista McAuliffe, the teacher that was to fly in space. And at that point in my life, I had never known any astronauts because they were all, in my mind, test pilots. And they had the right stuff. I wasn't quite sure what that was, but they had it. And until Krista McAuliffe became a household word, I didn't realize that people that I spent every day with, most of my day, who are teachers, had the right stuff too. And because of Krista McAuliffe and Barbara Morgan, of course, I realized that I could learn how to have the right stuff, because these teachers were people who impacted my life every day. And they were people who I saw more during the day than I did my own parents. And these teachers were not just people who instructed me on specific subjects, but they were my coaches and my advisors and my mentors, and in a lot of cases, my friends who would see me in bad days and see me in good days. So it inspired me. I looked back at, I started to look more into the astronaut program to see what it took to become an astronaut, and it specified a little more than just applying with an application, but that they were people who were interested in science and engineering, that we were building a space station and moving on to an international space station. These astronauts needed to be in good shape. They needed to help construct the International Space Station. And the more I looked into that, the more I looked back at my list and saw that many of my interests were a part of something that was already a big moving on in history, and I wanted to be a part of that. And so that's kind of my story, long-winded.
I'd just like to add something really quickly to that. I'm a Canadian astronaut, and in our program we have a smaller program, so we only have a selection roughly every 10 years or so. The last time we selected astronauts was in 1992. We had over 5,000 applications from all over the country, 600 of which were from kids less than 10 years of age. So there's nothing wrong. Get those applications in. It's a good thing.
Okay, the question I want to ask is, looking at Neil Armstrong going to the moon, I don't know if y'all are that young, Neil Armstrong, the Sputnik event and so forth, did that motivate any of you to want to be astronauts?
Yeah, for me, it was Apollo 7, watching that crew go into space. I was just starting first grade when that happened, and our principal came out right here in Washington, D.C., actually, back then, and rolled out one of those black and white TV sets and stopped our class, which I thought was pretty cool. I wasn't interested in the class that day very much, and said, history's about to happen here. We've just started a program where we're going to go to the moon, and you need to bear witness to it. I watched that launch go on, and first off, I was rather shocked that anybody had the audacity to try and reach the moon. I didn't think it was possible to get that far, and I really didn't think they'd succeed, but I was going to watch with rapt attention while they tried to do this. And between Apollo 7 and Apollo 11 was when I really formed my ambition to become an astronaut, because it looked like fun.
As an engineering student in George Mason University, I have a question for you. All this knowledge and filling out applications and stuff like that, how did it change your perspective about life and science and everything? I mean,
Barb?
Oh, that's a hard question.
Yeah, no. That's why I'm asking you to answer it.
For me personally, I don't think it changed my perspective on life, but it reinforced what I felt was really important, and that is that our universe is an incredible place. We know this much about it, and what we do know, we think, is that it's constantly expanding, which means that we're always going to know just this much about it in relationship. And so it provides just a never-ending, open-ended land of opportunities for all of us, and especially for you kids at your age.
I'll jump in here too, Barb. I don't know if you've ever read the writings by Mark Twain, but he talks about when he was a little boy on the banks of the Mississippi, just being enamored of the romance of being a riverboat pilot and running up and down, and he went about doing that and became a riverboat captain. And by the time he'd gotten through doing that, he no longer really saw the romance of it. He saw that there were the eddies and swirls and shoals, things that could wreck his boat. He had a much more of a technical view of things, and somewhere in there he had to struggle to keep in touch with the romantic side of it. And I don't know about these guys, but for me it's the same thing. And for me at 7 years old, it was all the romance of riding rocket ships to the moon, and now it's about checklists and procedures and making sure that we don't do anything wrong on these missions. And so every now and again you have to step back and go, hey, look at it from that 7 or 8 year old's perspective, and really kind of revel in the glory of it. Although it's tougher to do as you get older.
I think that's well put.
What does it feel like to be in zero gravity?
Well, microgravity makes floating's fun, certainly. However, it makes many of the things you do more difficult. Imagine your room. If you couldn't put anything on the floor or, on your desk, everything you use has to be put away. It has to be put in a closet or in your pocket or Velcroed. In fact, there's two things I think that are easier because of microgravity. Everything else is more difficult. Sleeping's more difficult, I think. And the two things is moving things that are very, very heavy, because they no longer have any weight, although they still have mass. So you have to be careful with them. You can't move something that weighs hundreds of pounds very quickly, because it could break something, particularly yourself. And getting behind objects, like if you had to get behind a piece of equipment to repair it, it's a lot easier when you can just float behind it. But it makes everything else, I think, more difficult to do.
But even though it's more difficult, it's still, the fun takes over. It's a lot of fun.
As an extension to that question, can you talk a little more about the medical and physical concerns with being in space, as far as is there more of an issue of like muscle fatigue and like I'm sure you can't do as much as you can on the ground?
That's a great question. In many ways, the body reacts to space similarly to if you were in bed here on Earth or as we get older. And when we go to space, we have problems with our muscles wasting. We're not as strong when we've been in space for 4 or 5 months as we are when we launch, and our bone density decreases and things. We're trying to do research to understand how we can prevent these problems, because once we go beyond the space station, back to the moon and go on to Mars, those missions are going to increase in length. So when we send humans to Mars, we want to make sure when they land, their muscles are strong, their bone density is maintained. But there's some really interesting physiological questions. Why is it that our bone density decreases in space, can reverse when we land, but if we get older here on Earth, our bone density just continues to decrease? We can't seem to reverse that process without resorting to medications and things. So a lot of the lessons we're learning about how we adapt to space are directly applicable on how we take care of patients here on the ground.
Yes, ma'am.
What made you want to be an astronaut and go out into space?
You want to try that?
For me, it was pretty simple. Like Tracy had a pretty good description of the different categories of astronauts and how you view them. For me, it was very simple. I've loved aviation from the time I was a little kid. When I was living in Alaska, my dad took me on my first plane ride, and from that point on, I had a passion for flying. And for me, like Al said, looking at what was done with the moon landing, and that being the just the ultimate experience for a pilot, that is how I set my goal.
Question in the back here.
Okay.
Thank you. We were just wondering what kind of physical exercises or training you have to go through in order to prepare for your missions.
Dave?
Yeah, I think a lot of that depends on how old you are. See, I was 53 this time, and I approached this quite a bit differently than the last time I flew in space 10 years ago. But typically, we have an exercise program where we're going to the gym usually 4 to 5 days a week, and we combine aerobic training with resistive training. So from an aerobic perspective, a lot of astronauts like running, and we'll go out and run 3-4 miles at a time. Some people prefer swimming, because it's not as hard on your joints, so you might get in the water and swim half a mile or so. And then, of course, we have a whole array of equipment available to us, from elliptical trainers to cycloergometers. But that's only part of the equation. The other part of the equation is making sure that you optimize your bone density and your muscle strength before you go. To do that, you have to be lifting weights, and there's really no other way to do this. So we've got a great program. We've got trainers specifically assigned to work with us at the gym, and we would spend anywhere between 2 and 3 hours at the gym. In my case, it took me a little longer. I'd be there 4 or 5 days a week, 3 hours at a time sometimes, working out.
One more question in the back.
The question is in regards to that bone density. If you're out too long in space, is it possible that theoretically you might not be able to come back to Earth because of the 1G if you're out too long?
Yeah, that's a great question. If you lose bone density continually while you're in space, at what point does this stop? I mean, people worry, are you going to become like a jellyfish where you don't have any bones at all after a certain point in time? And the answer to that is quite interesting. We don't really know the absolute length that you can stay safely in 0G. It's certainly beyond a year, but whether it's a year and a half, 2 years, we don't know. But I think if you look at a similar situation on Earth where patients have spinal cord injuries and they're in a wheelchair for the rest of their life,
lives, their bone density decreases, but it gets to a point where it begins to plateau. And I think you would see the same phenomenon taking place in space if someone were in 0G for a very, very long period of time. And the interesting thing, though, is that now with modern research, we're now looking at patients who have spinal cord injuries and trying to challenge ourselves clinically to see if we can get them back up and walking again. There's evidence that people have incomplete damage to their spinal cord. So one of the challenges is to take what we're learning in spaceflight about how to maintain bone density and apply it to patients with spinal cord injury to help maintain their bone density while we're looking at a way to help them recover and maybe get back up and start walking again. So these are all really interesting areas, and what we find is there's a lot of interdisciplinary research between what's going on in the ground clinically, what we're doing in space, and what we're doing in space and applying that back in the hospital on the ground.
Yes, sir.
How is it in space? Like, is it, like, do you feel like you're floating or flying? Or other stuff?
Barb?
Yeah, kind of both. Do you mean, do you feel like your body's flying? Is that what you're asking? When you can just hang there really quietly without moving at all, and you feel like you're floating. When you're working, as Scott mentioned earlier, when it's really challenging because things just don't stay put, they're all floating, you're floating there with them. You can also do, one of the fun things we like to do, we had a space hab back in the back of the shuttle with a long tunnel in between, and we spent a lot of time going back and forth between the mid-deck area and the shuttle, and we like to push as quickly as we could, very carefully, so we don't hit the ceiling and the bottom of the tunnel all the way down, but we try to go as straight as we could and push fast, so you did feel like you were flying through that tunnel.
You know, there are a lot of things that are great about flying in space. Certainly, you know, the floating that Barb described here. Looking out the window is a fantastic view. The ascent is an incredible feeling of power. The amount of thrust that gets us into space, 7 million pounds of thrust, and the acceleration to get us out to Mach 25. The entry, certainly very exciting, coming back from a successful mission. But you know, what I try to tell kids out there when I go talk to them at their schools, and other folks for that matter, is honestly, for me, the best part about being an astronaut and working for NASA and having the privilege, because I think it is a privilege, of being able to fly in space, is working on something that you believe strongly about, something that's larger than yourself, something that's very, very difficult and challenging, working hard at it and being successful, working with a great team, both your fellow crew members and all the people that make these missions happen. And I think that's something that kids in particular can look forward to in their futures. It's things that they can experience with their schoolwork, in any sports teams they're in, and that is you know, working hard on something that's difficult and then being proud of yourselves when you do a good job at it. Yes, sir.
Yes, Dane Robertson from Howard University. I'm a math and physics double major, and my intentions was to actually pilot. So what would be the best route for me to take now that I've...
Going to Marine Corps.
Unless, of course, you can go in the Navy.
But don't go in the Air Force.
Also, to branch off that, I want to know, what are you going to do now that you're back? What are your plans?
Well, to answer both of your questions, I think if you want to be a pilot and you wanted to be a pilot of a spacecraft in the future, probably a good route to go would become a military test pilot. Although I'm not sure what the requirements will be for the next vehicle that we fly, the crew exploration vehicle. But certainly, being a military test pilot gives you some pretty high level of qualifications for piloting anything.
Well, it gives you right now, you know, from the very beginning till now, it's been the only way to come in as a pilot astronaut.
I think you get the best experience flying that way.
And me personally, what I'm going to do is I'll continue to work in the astronaut office and hope to fly again on either a shuttle mission or a space station mission or the crew exploration vehicle. And I would imagine everyone else feels probably in a similar way.
I've talked to a couple people fly to different airports. There's people working there at the gassing the planes up that are doing kind of what you're talking about. You know, they're going through college and they're trying to get their pilot rating. And some of them I've talked to go, how much you paying for this? Like $50,000-$60,000 these days. I go, hey man, let me tell you, when I was a kid, I would fly about 1 hour a month, and I was flying airplanes before I was driving cars, and it was very difficult to afford, but it was a great thing to do. So I just loved it. But you know, you're paying all this extra money. You're scraping dishes. You're cleaning up horse barns, doing whatever you can to make the bucks to do it. And then I joined the military, and they not only did they pay me to do that, they paid me extra to do it. So really, it is the way to go.
But this is my last question. I want to know, how did your diet change for you to get prepared? That was my final question, being that we are talking about muscle mass as well as bone density. I want to know how your diet changed for you to be prepared for this flight.
You want a doctor to answer that, or a plumber?
Let's start with the plumber.
Ahead, Dave. Let me answer it from the basic person standpoint, which I am, and that's it. I tried to eat as much as I could when I was up there, and I have a fairly robust diet, you know, going into it. And I tried, you know, when you work with a dietitian and you get to sample all the foods, and yeah, this isn't so good, and I can't stand blueberries, but I really like the meats, you know, and so you pick exactly what you want, and I took that and I did about 1.5 times what I thought I'd eat, and I tried to eat everything in sight, and I still lost 8 pounds in 2 weeks. In my first flight, I lost about 6 pounds, so I can't really tell you why. I thought I was far exceeding the dietitian's expectations of what's required, but it's hard to eat. It's hard to find time to eat because you're very busy. It's inconvenient to eat when you're in space, so you try to find foods that you can just cart along with you and just start chowing down on anytime you want. When the spacewalkers are out, they can't eat for like 8-9 hours probably from the time they start putting their suits on to the time they get out of their suits. So nutrition's kind of tough. So I'll let the doctor answer now.
Yeah, Scorch gave you a really good answer. I think the key to success is to have a well-balanced diet, and the challenge, of course, is being able to do that in the absence of gravity, trying to eat fast, eating on the run. A lot of us were eating protein supplements and these nutrition bars, you know, having those with high protein content. Taking multiple vitamins every day is a good thing to do in space, and antioxidants, just like it is on the ground. And one of the interesting things about food is boredom. You know, if you eat from the same menu every day, after about 4 or 5 months, you kind of get bored with this. And that's going to be one of our biggest challenges when we think about sending crews back to the moon and on to Mars. How do we give them food that's interesting and exciting, palatable, that they want to eat for 3 years in a row, so they're not pulling out, you know, it's mac and cheese for breakfast again. But anyway, eating in space is kind of interesting. One other little anecdote that I'll share with you is when you're in space for the first couple of days, it feels like you've got a cold. Your face is really puffy. So astronauts like really spicy foods, and one of the really popular ones is shrimp cocktail, particularly for that reason.
Yes, ma'am. How do you move around in space? You know, when you first get up there, you think, wow, I'm moving around really, really well just by, you know, pushing off the wall, and your feet are very important because that's how you secure yourself from floating away. You put your feet in under things. We have these little toe holds. So, but it's interesting, after you've been in space for, you know, a number of days, a week, let's say, you think back to your first day and you think, wow, I was using about 100 times more force than I really needed to move around. And the longer you're in space, the better you get at it. But you know, it's interesting how every once in a while you just completely like spaz out and start knocking things off the wall. Yes, sir. How does space look at night?
No, when you get your first glance at
First glance at space.
Does anyone have a first look out the window story?
Yeah, when I took off, I was on the mid-deck, so the cockpit in our shuttle is a 2-story cockpit, and only the top deck has windows on it. So we were down without any windows. For about the first hour and a half, we were busy just unpacking, getting ready for space flight. And somewhere along there, I had to go up to the flight deck to go grab something. And when I went by, after about an hour and a half of being in space, got to my first view out the window, and it just stopped me in my tracks. Just seeing the blackness of space out there and the curvature of the Earth, and this thin layer of atmosphere between the Earth and space just really slowed me down at a time I really need to be moving quickly. But even when you've got things on your mind, it'll stop you. It's very profound. The young lady over in the corner, she's had her mic for a while, waiting patiently.
How did you feel when you first became an astronaut?
Tracy?
Actually, I hyperventilated. And the chief of the office had to call me back 30 minutes later so he could finish telling you everything he needed to tell me. So,
Make sure she was still conscious.
Yeah, yeah. And I had I was working at a university, and when I got the call that said I was an astronaut, I went, after I caught my breath and hung up the phone, I went screaming down the hallway, yelling, "I made it! I made it! I made!" And people didn't even know who I was, some of the kids. And by the time I got back to the phone and spoke to the chief of the astronaut office, he said, you know, Tracy, I probably should have told you this before we got off the phone, but in an hour from now there'll be a press release that goes out with your name and the rest of your classmates' name announcing you as the new class, so or 24 hours from now. So until then, we'd like you to limit the news to just your immediate family. And right then, I went from total elation to complete fear that maybe I wasn't an astronaut anymore. But needless to say, I was extremely excited.
Who else has a mic? Okay.
Yeah.
How long do you get to stay in space?
How long you get to stay? It depends on what you're doing. For those of us on our mission, we were up for just under 13 days. Most shuttle missions last no more than 2 weeks because we just don't have enough things on board, air, food, and water to go longer than that. For the space station, those missions can last 6 months, sometimes 7, 8, 9 months, because that's what they're there for, is for longer missions. They've got resupply from space shuttles and Russian rockets that bring up everything else they need to do. But I don't think anybody stayed up for more than, what, about 400 days? That's about the limit. I think the Russians have done that. And typically after 6 months, you start to miss your friends at home anyway.
Our crewmates feel...
Yeah, we got time for 2 more questions. Why not this young lady right here in the front?
Was you scared when you first got in space?
You're supposed to be scared before you go in space.
Yeah.
After you get there, it's a little too late.
I think what that's a fair question to ask, and a lot of people, you know, really wonder if you're scared before you go in space, because there is a lot to fear. But for us, I think to a man, woman, however you want to rank that, I don't think anybody had any fear because you're so well prepared for what you're going to have. Once you're in space, it's nothing but joy and fun. The only thing you really do fear is making sure you know what you're doing next and you don't mess anything up that could turn something south.
Can we get time for one more? Yes, sir.
How much did you have to do to become an astronaut?
How much did you have to do? You know, sometimes I get the feeling that I've been in school almost continuously since kindergarten. So, you know, whether it's, you know, elementary school, high school, college, graduate school, flight school, test pilot school, astronaut training, it's a lot of work, but it's also very exciting work and very rewarding. And, you know, what I tell kids, if they want to become an astronaut, I think what's important is that they first never stop trying, and because that really limits your options if you just give up. But also choose something that interests them, that interests you, because if it's a field you're interested in it, you'll tend to do better in it. And you know, I think it's important for you to enjoy what you're doing as a career, whatever that career might be. With that last question, I'd like to again thank everyone for showing up today. We really appreciate it, especially all the really smart questions that the kids asked here today. Thank you.
And, I'd like to thank everyone who took the time to come out this morning. Again, thank our Deputy Administrator, Shannon Dale, for being here. And one more time, the STS-118 crew. Thank you.